These are notes 3.1. Okay, we're going to start talking about imaginary numbers and complex numbers. An imaginary number is basically just when you take the square root of a negative number, we know that nothing times itself will give you -1. So somebody came up with this imaginary number, so we use the I. So the square root of a -1 is I. That's our imaginary unit. Now, if you think about this also, if I would square both sides, I would get that -1 is equal to I squared. Okay, so if I square both sides, I squared would equal square root cancel out, we get -1. So those are two properties we want to think about there. Now a complex number is just of the form a plus bi. So for example, 2 plus 3i would be a complex number. So we have a real part to it and we have an imaginary part to it. I'm not going to ask you to do this, but they do take these and graph these. So the 2 is a real part, so this is like, instead of the x, we call that the real, and this is the imaginary, and that would be 3. Okay, so you could graph these. There's actually something called the Mandelbrot set if you want to look into that, and a lot of fractal things that go into these things, but we're not going to get into that. Okay, so we'll just do a couple examples here. The square root of 4, you know, is 2, because 2 times 2 equals 4, right? Now, does anything times itself equal -4? No, not times itself, nothing squared. So what we do is we say this is a square root of -1 times the square root of 4. Now, the square root of 4 we know is 2. The square root of -1 we said was I, so it's just 2i. So the square root of -25 is the square root of -1 times the square root of 25, which would be 5i. Okay. Square root of -36. Okay, so this would be 6i, and then the negative out front just makes the whole thing negative. Also, if you're solving this, okay, remember taking the square root of both sides. So you get x equals, and I don't know if you remember this, but hopefully you do. We could have plus or minus, right? And the square root of -25 would be 5. So 5i and -5 would be your answers. To solve this, you could subtract 100 to the other side and take the square root, and we get an answer of, everybody, yes, you're right, plus or minus 10i. Okay, so that's a little bit there. Okay, so reducing these. Hopefully you remember this from Algebra 1 and Algebra 2, but maybe not. So we'll see. Okay, so we want to break this down and try and simplify this, because there's nothing times itself that gives it 75, right? Not whole numbers anyway. So we're going to simplify. So I can split this. 75 is 25 times 3. 25 is 5 times 5. So 75 is really 5 times 5 times 3. Okay? I like to cross out the things above it so you know you're just left with these prime factors. Okay? Now, 5 times 5 is 25. And then we have the 3, right? So the square root of 25 is 5. And the square root of 3 doesn't simplify, so we're going to leave that as the square root of 3. And the square root of a negative number is imaginary. Okay? Square root of -32. Okay, 32, if you break it up, you can do 8 times 4, and that's 4 times 2. Okay, now we notice we have 4 times 4 here, right? So that's kind of like this idea. Whenever you see a pair, that simplifies, right? 5 times 5 is 25. Square root of 25 would be 5. Okay? Same thing here. 4 times 4 is 16. Square root of 16 is 4. It's a square root of a negative, so it's I. And the 2 does not simplify, so we'll leave that there. Now, you could have also taken that down farther and gone like this, right? So we would have 2 times 2 is square root is 2. Okay, 2 times 2 is 4, square root is 2, so 2 times 2 gives you that 4 there as well. Okay, and then that square root of 2 doesn't simplify, so you have that. Okay, try and pause the video and work these out and then come back. Okay, 27 is 9 times 3, 9 is 3 times 3, so I see a pair here. So my answer is 3i square root of 3. 3 doesn't simplify. 200. Okay, is 100 times 2, and then 100, I can simplify, I know it's 10 times 10, so I see that pair. Or you could split it up different ways. Eventually you would get 2 and 5 and 2 and 5, okay? So if you see this, I see a pair of 2s and a pair of 5s, okay? So the 2 and the 5 go out front, which is 10, right? And then this 2 doesn't work out, so that's going to stay on the inside. And since it's negative, we know it's going to be imaginary. Okay? 169 would be 13 times 13. Okay, so this works out evenly, doesn't it? We got a pair already. So we have 13i would be our answer. Nothing left over that didn't simplify. Okay, so 486. I don't know off the top of my head, but I know it's even. So I'm just going to divide it by 2. So it's 243 and 2. And then 243. I'm using my calculator here to decide. Okay, is 3 times 81. Sometimes it takes a little bit to find that, and 81 is 9 times 9. If you want to go farther, you could say 3 and 3. If we get it all the way down to prime factors, or you can just use the 8s there right away. But if you go to prime factors, we have this. So what goes out front is a 3 times a 3. And then these two are stay inside because they don't have a pair. They can't be broken down, so you have 3 times 2 inside. So you have 9, and it's negative, so I square root of 6. Okay. Next ones, we're multiplying here. So if we multiply these together, you could do it different ways. If I just multiply, it'd be the square root of 49, which is 7. Or I could say this is I square root of 7 times I square root of 7, which is I squared square root of 49. Okay, actually scrap this one. So we're going to pull out the I in both of them first, okay? So I times I gives you the I squared and 49. I squared, we set up here, was equal to a negative 1. So we have negative, and the square root of 49 is 7. And you can also think about that here, right? We're multiplying it by itself, so squaring it and square root kind of cancel each other out. So this one here, we have, since it's negative, we have I square root of 6 and negative I square root of 10. So if I multiply those, I have I squared square root of 60. Okay, 60 I can simplify into 3 and 20, 4 and 5, 2 and 2. So I see a pair there, so I have 2. And then the 3 and the 5 don't work out, so those stay inside, 15. And I squared makes it negative. Okay. These here, I can divide them. So this would be, well, we'll do this first. Pull out the I square root of 20 and I square root of 2. I divided by I would just be 1. And the square root of 20 over the square root of 2 would be the square root of 10. And 10 only simplifies to be 2 and 5, but there's no pairs, so there's no perfect square that comes out of that. It can't simplify. This one here would be I square root of 48 divided by the square root of 24. We know 48 divided by 24 is 2, so we'd have I square root of 2. 2 doesn't simplify either, so you're done there. Okay, next one's here. 17. Okay, we're adding these together. It's really the same idea as if I did 2 plus 3x, and I'm adding to that 4 plus 5x, right? We're just looking for like terms. 2 plus 4 is 6, and then 3x plus 5x is 8x. Same idea here. So if we add those like terms, 3 plus negative 1 is 1, negative 4i plus 6i is positive 2i. Okay, do the next one here. Okay, adding like terms would be negative 6, and 7i minus 15i would be negative 8i. Now with subtraction, a lot of your teachers probably told you to distribute that negative through, which is a good idea, and then add your like terms. So we have negative 10, adding your i's together, plus 10i. Once again, pause it and do it yourself. Okay, adding them together would be 4, negative 5 plus I plus 3I is negative 2I. Okay, so that's just your adding and subtracting. Number 21, we are now multiplying. Okay, so we got to use our double distribute or FOIL or whatever you were taught. So 5 times 7 is 35. 5 times negative 2 would be negative 10I. Negative 28I. And positive 8I squared. Okay, now we know that these two are both i's, so we can combine those together. So negative 10 and negative 28 is negative 38i's. Now here's the thing, we got to make sure we simplify this. We had said at the top here that I squared is equal to negative 1. So we have to take this I squared and put a negative 1 there. So we have 8 times negative 1, which makes negative 8. And then I can combine that with this 35. So 35 minus 8 gives you 27. And the way we write a complex number, we had said at the top here, was the real part and then the imaginary part. So we have the real part and then the imaginary part. Okay? So the next one, multiply through. So we have 36 minus 30i plus 30i and negative 25i squared. Okay? Notice when we combine the i's together in the middle, they cancel out. Okay, they cancel out. So then I would just have 36. I squared is a negative 1. So negative 25 times negative 1 is plus 25. And then 36 plus your 25 gives you 61 with no i's. Okay, now notice the i's cancel out. This is going to be important when we do something a little bit later tomorrow. So these are called conjugates of each other. So 6 plus a number and 6 minus a number, right? So notice if it's plus the same number and minus the same numbers, the middle terms are going to cancel out in there. Okay, those are called conjugates. Okay, if I square something, I know you have to multiply those together. So 4 plus 3i times 4 plus 3i. Okay, multiply it through. You can do it yourself. Pause it and check back. Plus 12i plus 12i plus 9i squared. 12i plus 12i is 24i. And then 16 and I squared is negative 1. So this would be negative 9. 16 minus 9 would be 7. Okay, pause it and try this one. So you get 4 minus 10i minus 10i plus 25i squared. Okay, if you do the real, you can do any part first, but this makes this a negative 25, right? I squared. So 4 minus 25 would be negative 21. And then negative 10i minus 10i would be negative 20i. Okay. Number 25. Okay, we're going to powers of I here. Actually, I think the first day of 3.1, we're going to stop right there. So if you want to watch the rest of the video on the second day, that would be good. Actually, I'll just stop it here.